Good day! I am Roxette Chenice, the Alarcon of grade 11 STEM Del Mundo. Today, I'll teach you how to solve problems about limiting reactant. Remember, solving limiting reactant is hierarchical, meaning we have to understand how to balance equations first and get the molar mass percentage composition of the reactants before you're able to solve limiting reactant problems. I'll show you what I mean. Let's start with balancing equations. We have here NH3 plus O as reactants and H2O plus NO as products. To know if they are balanced, let us write down the elements and their subscripts. Subscript is commonly the small in size number on the right side of an element, which indicates the number of atoms, like the imaginary number 1 of nitrogen, 3 of hydrogen, and 1 of oxygen. Let's move on to the product side. Here, nitrogen has 1, hydrogen has 2, as well as the oxygen. As you see, nitrogen is the only balanced element in this equation. That's why we have to do something. Let's start with a big number, hydrogen. On the right side of the equation, 2 is smaller than 3 on the left side. So, we have to put a coefficient with the elements that can make them balance. So, if I put 3 here, we have to multiply this to hydrogens 2 to make it 6. Same goes with oxygen. We have now 3 oxygen plus 1 equals 4 oxygen. They are still not balanced, so let us put 2 here, making nitrogen 2 and hydrogen 6. By putting 2 here, it's now balanced. But the value of oxygen has changed. Don't you worry, we just have to add their coefficients, making oxygen 5. Lastly, by putting 5 as coefficient of oxygen on the left side, we have now 5 oxygen. Now, it's balanced. Do you understand? Let's try another example. AuCl4 plus AgNO3 resulting to AgCl2 plus Au plus NO3. Same process. Write down the elements and put their subscripts. On the left side, Au has 1, Cl has 4, Ag has 1, nitrogen has 1, O has 3. On the right side, Au has 1, Cl has 2, Ag has 1, nitrogen has 1, oxygen has 3. As you see, Cl is unbalanced. So, we have to put 4 here, making it 8. Since coefficient 4 also belongs to Ag, we have to multiply it by Ag's 1, making it 4. On the left side, by putting 2 there, we made Cl8 and Au2. To balance Au from the right, we have to put 2 there. By putting 4 as coefficient of AgNO3, Ag is now 4, N is 4, and oxygen is 12. Same goes with the right side. 4 times nitrogen's 1 is 4, 4 times oxygen's 3 is 12. Next step, molar mass percentage composition. As example, we have C6H12O6. The formula is reactant subscript times molar mass. Through your periodic table or search engine, you would know that carbon's molar mass is 12.0. Multiplying it by the subscript 6, making it 72.06. Next, hydrogen 12 times 1.01 molar mass equals 12.12. Next, subscript 6 times the molar mass of 16 equals 96. Add them all with a total of 180.18 grams per mole. To get the percentage composition, this is the formula. Molar mass divided by total grams per mole. Then multiplying the quotient by 100. Through substitution, percentage carbon equals 72.06 over 180.18 grams per mole equals 0.40 grams per mole times 100 equals 40%. Next, hydrogen. 12.12 divided by 180.18 grams per mole equals 0.07 grams per mole times 100 equals 7%. Lastly, oxygen equals 96 divided by 180.18 grams per mole equals 0.53 grams per mole times 100 equals 53%. Adding them all would give us 100%. Remember, in molar mass percentage composition, the final answer should always be 100%. If not, then there's something wrong with your solution. I presume that you're now ready to solve limiting reactant problems. Here's the steps. Step 1, balance the chemical equation. Step 2, convert reactants into moles. Step 3, divide the coefficient. And Step 4, identify the reactant with smaller number than it is the limiting reactant. Number 1. Identify the limiting reactant when 58.02 grams of aluminum reacts with a 77.21 grams bromine 3 to produce Al2Br6. First, let's see if we have to balance the equation. On the left side, Al has 1 and bromine has 3. On the right side, Al has 2 and bromine has 6. They are unbalanced, so the way I see it, if I put 2 on both Al and bromine 3, Al would be 2 and bromine 3 would be 6, and they are now balanced. Step 2. Converting reactants into moles. Al subscript is 1 times the smaller mass of 27 equals 27 grams per mole. Bromine subscript 3 times its smaller mass 79.90 equals 239.7 grams per mole. Next, we have to divide the reactants in grams by their molar mass in grams per mole. Let's do some cancellation of units. Then 58.02 divided by 27 moles equals 2.15 moles. For bromine 3, 77.21 divided by 239.7 moles equals 0.32 moles. Then step 3. Divide them by their coefficients. Al has 2 as well as bromine 3. So, 2.15 moles divided by 2 equals 1.075 mole. For bromine, 0.32 moles divided by 2 equals 0.16 mole. For the final step, the limiting reactant is the smaller number. Therefore, 0.16 is the limiting reactant in this problem. Problem number 2. Identify the limiting reactant when 5.0 grams of potassium hydroxide reacts with a 16.0 grams carbon dioxide to produce K2CO3 and water. First, balancing equation. KOH plus CO2 resulting to K2CO3 plus H2O. Let's begin balancing the large numbers first, which is oxygen. If I put 2 here, K1 would be 2, O3 would be 4, H1 would be 2. Wow, so easy to balance. Next, converting reactants into moles. Since K, O, and H have subscripts of 1, we just have to write down and combine their molar masses, resulting to 56.01 grams per mole. For CO2, 1 times 12.01 equals 12.01. Then oxygen subscript of 2 times its molar mass 16 equals 32. Combine them, resulting to 44.01 grams per mole. Always remember that on the right, we have KOH and on the left, we have CO2. Again, reactants per grams divided by molar mass is the solution here. Therefore, for KOH, 5.0 grams divided by 56.01 grams per mole is equal to 0.09 mole. Divided by its coefficient, and we got 0.045 mole. For CO2, 16.0 grams divided by 44.01 grams per mole equals 0.36 mole. CO2 has no coefficient, but still, if you want to divide it by 1, the answer would be 0.36 mole. Next, the smaller number is the limiting reactant. Therefore, 0.045 or 0.05 mole of KOH is the limiting reactant in this problem. Woohoo! Finally, we're done! I hope you learned from me. Bye-bye! And thank you!